All right, so let's tie this all together, okay? So the beginning of this, we expanded a plus b to the 0 power, a plus b to the first, a plus b to the second, the third, and so on. And what you can see is the patterns that we have right here. We started with 1, and then we had 1a plus 1b. We had 1a squared plus 2ab plus b squared, and so on. But what I want you to focus on is just looking at the coefficients. We start with 1. And then we have 1, 1. That's the only part of this you have to memorize. Well, I guess let me rephrase that. Don't memorize that. Memorize that 1s go on the outside. That's a better way to look at this. How do we get that 2? Well, 1 plus 1 equals 2. Okay? How do we get this 3? 1 plus 2 equals 3. 2 plus 1 equals 3. How do we get this 4? 1 plus 3 equals 4. 3 plus 3 equals 6. 3 plus 1 equals 4. So we should see that we get the inside of Pascal's triangle by adding the coefficients above. Okay, this is super, super huge for us because if we don't know this, we have to use that crazy formula that I ain't using. Okay, so how does this help us expand the two problems below? Well, the first thing we need to know is that we're going to start with 1a to the third power, b to the 0 power. Plus, we're looking at our third row. So we're looking at what I'm about to highlight in green. So I know my next coefficient is going to be a 3. And here, watch what I do. I take one less exponent on a squared, and one more exponent on b, so b to the first, plus another 3. I take one less a, so a to the first, b to the second, and then my last one will be 1b cubed. So look at my exponents. They always add up to 3. 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. And I made a lazy mistake on the last one, so let me fix that one really quick. Just to keep with the pattern, I should have written 1a to the 0, b to the third. So the a's go down by 1 exponent while the b's go up by 1, and I follow the coefficients of Pascal's triangle. Okay, so let's apply that to the next crazy looking one. We have 2x minus 3y to the third. Okay, well, what do we know? We know since it's to the third power, it's the same exact line that we just used, which makes this one a little easier. So we can say that this will equal, well, let's think about this. 1, 3, 3, 1. Let me move my head out of the way here. Okay, well, what do I put next? I'm going to put 2x, negative 3y, 2x, negative 3y, 2x, negative 3y, and then with plus 1 times 2x, negative 3y. So what did I do? I went 1, 3, 3, 1. So I put my coefficients in. Then I took each of these parts, the 2x and the negative 3y, I put them in parentheses next to each one. What's the last thing I have to do? My exponents. I'm going to start with a 3 and a 0, 2, 1, 1, 2, 0, 3. I can assure you this is a much easier way to look at this than to actually use the that crazy formula. So now we just got to clean it up. So let's see. Negative 3 out of 0 goes away. So we're going to get, let's see, 2 cubed is 8. So we're going to get 8x cubed plus 3. Let's see, 2x squared would give me, so times, let me redo that part. So times 4x squared times negative 3y plus 3 times 2x. Let's see, negative 3 squared is 9. So times 9y squared plus, my last one, let's see, negative 3 cubed is negative 27 So plus negative